So all of this is just from the prompt. You don't need to do anything about that, right? But now we're doing it by wrong thing. Contrapositive, right? And for a contrapositive, what you want to do is you just want to do a double flip. So the implication changes and you negate the whole thing. So here's a nice way to do it. You take the end of this, right? That's going to be here. The implication error is going to be in the middle as always. This thing. Now you're going to bring it all the way here. And you negate it now. So n is a multiple of 3. N is not a multiple of 3. N squared is a multiple of 3. N squared is not a multiple of 3. Right? And then now you just look at the prompt, right? So if n is not a multiple of 3, we know that that's going to be this thing, right? So if n is not a multiple of 3, then n is equal to 3k plus 1, or n is equal to 3k plus 2, right? And now we just do algebra. N squared, if n is equal to 3k plus 1, would be 3k plus 1 squared, or 3k plus 2 squared. But remember the bigger picture, right? You're trying to prove this contrapositive statement. You're trying to prove it true, because if this is true, that means the original proposition, this thing, is also true, right? So we're just trying to prove it right. So 3k plus 1 squared, that's 3k plus 1 times 3k plus 1, which is going to give you 9k squared plus 6k plus 1. And this thing is going to give you 3k plus 2, 3k plus 2, 9k squared plus 6 is 12k plus 4, right? After you get these, what you're trying to do is you're trying to show that these two are not a multiple of 3. If something is not a multiple of 3, it should be in this form or this form. So now, you just look at it, and then you realize you can factor out a 3, right? This can be 3k squared plus 2k plus 1. And now, if you look at it, that has the same format as this, because 3k plus 1 can be written like that. 3k squared plus 2k plus 1, or basically just pattern matching. This thing can be there, right? This k value is this expression. Now the 3 is just 3. So this is already done. This thing is a bit hard. 9k squared. Wait. For this one, it's not that obvious to how you can get 3k plus 1 and 3k plus 2, right? But if you look at it, you can do 9k squared plus 12k plus 3 plus 1, because 3 plus 1 is 4. You can just break it down into like this, right? Now, you can factor the 3 from the first 3 terms. You can be like 3k squared plus 4k plus 1, and then the plus 1 at the end just is not factorable. Now, this thing is also in the form 3k plus 1. This thing is equivalent to that. This because 3k squared plus 4k plus 1 plus 1. This plus 1 is there. This k is this k in the parentheses. The 3 is the 3. Now the k just represents that, right? So now you can be like, since both of them are in the form 3k plus 1, which isn't a multiple of 3, now just state the proposition. N squared is a multiple of 3 implies n is a multiple of 3. And now you're done.